Welcome student. Today we will discuss line model and performance of transmission lines. Now this chapter deals with the representation and performance of transmission lines under normal operating conditions. Transmission lines have four distributed parameters: series resistance and inductance, and shunt capacitance and conductance. These parameters, together with the load current and power factor, determine the electrical performance of the line. By performance of lines is meant the determination of sending end voltage, sending end current, sending end power factor, power loss, efficiency, and regulation of lines during steady state and transient conditions. The values of receiving end voltage, receiving end current, and receiving end power factor are usually known. Transmission lines are usually operated with a balanced three-phase load, and hence the analysis can represent it on a per phase basis. The terminal voltages are expressed from one line to neutral, the current for one phase, and hence the balanced three-phase system is reduced to an equivalent single-phase system. For overhead transmission lines up to about 80 km are termed as short transmission lines, where the effects of shunt capacitance is neglected. The lines above 80 km and below 160 km length are termed as medium length lines. For medium length lines, the shunt capacitance of the line cannot be neglected, and it is considered to be lumped at one or more points of the line. The lines above 160 km are termed as long lines. For long lines, the parameters are distributed uniformly over the entire length of the line, and rigorous calculations are required. So, we will discuss now short transmission lines. The equivalent circuit for a short transmission line is shown in figure. Here, the following nomenclature has been adopted: R equal to resistance of both outgoing and return conductors, that is equal to 2 into resistance of one conductor. X equal to reactance of both ongoing and return conductors, that is equal to 2 into inductive reactance of one conductor. VR, voltage at the receiving end; Vs, voltage at the sending end; IR, current at the receiving end; Is, current at the sending end; Z, series impedance of the line, that is equal to R plus Jx; cos phi R, power factor of the receiving end or load; cos phi S, power factor at the sending end. The end of the line where load is connected is called the receiving end, and where source of supply is connected is called the sending end. Subscript S stands for a sending end quantity, and subscript R stands for a receiving end quantity. Now in short transmission line, Is equal to IR equal to I.